I'm Colin Toohey, and this is Talking Textiles, where we talk to successful companies and organizations about their experiences in the fabric industry. This podcast is brought to you by the Advanced Textiles Product Division of the Advanced Textiles Association, ATA, a not-for-profit association representing the international specialty fabrics marketplace. ATA hosts several exciting events throughout the year, including the annual expo happening this October 12th through 14th in Charlotte, North Carolina. Expo 2022 is the textiles and specialty fabric industry's flagship show for sourcing, networking, and education. To learn more about the expo and other upcoming events, please visit textiles.org/events. Today, we're interviewing Director Dan Walczyk and Senior Research Engineer Glenn Saunders from the Manufacturing Innovation Center at RPI, Rensselaer Polytechnic Institute. Dan and Glenn, welcome to the podcast.
Thank you, Colin.
Thank you.
So we're going to start at the beginning. We'll get into what you do and where you are right now, but we're going to talk a little bit about how you got to now. And we're going to look through the lens of manufacturing. So both of you guys, when did you start having a fascination with manufacturing? Was it after you started your professional careers, or were you always interested in factories and making your entire childhoods? Dan, you want to give it a go?
Sure. Well, I grew up in upstate New York, and there were two things going on. First off, I was a geek. I kind of knew I was going to be an engineer. So I like taking things apart and seeing how they were made. And sometimes they would put them back together. Sometimes there would be parts left out. And the other thing is that in upstate New York, it's one of the Rust Belt areas. So I saw a lot of cities losing manufacturing. So that always kind of concerned me. And it wasn't until, when I was after college and working that I was more on the design side, but I got to see how things were made. And it wasn't until graduate school that I really got pulled into the manufacturing world, I guess. And I've never looked back. So, it really was a combination of factors that, concern, interest, and opportunity that drew me into manufacturing.
Was there ever a factory you got to go to as a kid or saw something being made early on?
Yeah, I mean, actually the most interesting thing was locally in our hometown, there was a company that made automation equipment. And it wasn't mass production, it was one-offs, but I got to tour that, and I actually ended up working there for a couple of years.
Wow.
And so that was kind of my first exposure to manufacturing. I got to see machine shops, machines being built. Those machines would be used in factories as part of their automation.
Very cool. And Glenn, did you have a similar experience in your background, or did this all of a sudden start when you got a job at RPI?
No, it started long before that. So, so like Dan, it started at home. So my father was a teacher so at the time it was called industrial arts. So that was wood shop and printing and those kinds of things. And I don't know if schools still do that, but so basically we had a basement that was full of tools and supplies, and basically I started building stuff with my dad at a pretty early age, and that was sort of the genesis of becoming an engineer. But of course, at the time, I had no idea what an engineer was or what an engineer did, and in fact, didn't learn that until I got to college. At the time, high schools, they pretty much didn't. At least the guidance counselors I talked to didn't even know what engineering was. Pretty much, if you were good, if you got good grades in math and science, you could go to engineering schools, like RPI, but there was pretty much no discussion of what an engineer actually does. But I can say that even in high school, I found myself taking courses in mechanical drawing, which precedes CAD. We had no CAD at the time, so that was done on a board with a pencil and so forth. So I was taking drawing courses because that was what interested me over the other courses that my peers were taking. So at that point, I should have figured out that I was going to be an engineer. But again, I didn't even know what an engineer was at the time. when I got into RPI, and then got some exposure to what engineering really was, then it was a set of courses associated with robotics in manufacturing, and that was really the spark that led me to focus on manufacturing.
When I think manufacturing, I think factory and assembly line. You're talking about robotics, which may or may not include that. Do you kind of remember when you first saw automation in factories, or when you got your first factory tours, or what you saw being made?
At the time, robotics was pretty much industrial robots, which is what I've been focusing on. There was not a lot, the research in or the developments in the kinds of robots that we see nowadays, Mars rovers and all the rest of that. I mean, that was still research. There was none of that was mainstream. So it was pretty much industrial robots that I started with. I don't remember my first plant tour. I've been in so many places. I don't remember the first time the first time I saw it. But
for Glenn, it's like, oh, another one.
And if you saw, I mean, and Dan, you mentioned this earlier, you saw kind of as a Rust Belt in upstate that manufacturing was on the decline. Why enter the industry? Like, why is it interesting despite the reduction in manpower and labor in the manufacturing enterprise, especially in upstate New York? I mean, I know you all work globally, but how does your work and your interest in this industry coincide with sort of an offshoring, if you will, over the last few decades?
Well, I mean, that's an interesting question. What I produce is students, that go out, new engineers, many that are interested in manufacturing. So they're kind of taking up the sword for reshoring of manufacturing. And both of us do research. Actually, Glenn also teaches kind of off and on. He's teaching students all the time. So that's probably the biggest thing, the biggest impact we have. But we're also doing research. We're trying to advance the science and engineering of manufacturing, so that domestic companies can do better. And you always have the risk of foreign entities that are interested in IP, and then maybe don't respect the same way that most of the developed world does, of absconding that technology. But we still are trying to help U.S. companies. And interestingly, since COVID, you see a lot of reshoring, and that's kind of a boom for us. So I hope to see that continue.
I want to push back a little bit on the notion or the idea that manufacturing is on the decline. So if you look back historically, clearly, 50 years ago, it took 10 times as many people to make the products that we were making at the time. And there's been the number of people in manufacturing has decreased since that time. But if you look at what's happening today, we are manufacturing domestically tends to be, the more advanced products. Manufacturing as a sector is very, very strong. It's much smaller than it was 50 years ago, but it's very strong.
It's still about, I don't know, 11-12% of US GDP, right?
Mm-hmm.
Remember correctly.
Yeah.
So it's a big chunk of the economy.
Yeah, it's a big chunk, and it's important. I mean, there's a saying is that we can't just sell each other insurance all day. We have to be making products, and like I said, we're making the more advanced products, so we need advanced manufacturing domestically.
Yeah, and just to kind of reinforce what Glenn said, I mean, if pulling out some numbers, I think there's a 3-to-1 ratio of investment by manufacturing and the effect it has on the economy. So, if you look at the supply chain that has to grow up around a new plant, and all of the goods and services that are supplying a manufacturing plant, there's typically, again, a 3-to-1 ratio of the direct manufacturing investment and the effect it has on the local economy. So that's pretty compelling compared to other industries.
So getting into the nitty gritty of what you do at do you call it the MIC or the Manufacturing Innovation Center?
Yeah.
So what you've been doing, what percentage of your work is based in upstate New York in the United States? I mean, you're based in upstate New York in the United States. Are you working with companies that are taking your technologies that you innovate and do research on and bringing it globally? Is it mostly about domestic supply chain and domestic manufacturing, or are you agnostic as far as where what you do is going to end up?
Well, I'll start and then I'll let Glenn kind of add to it. We work with any company that has interesting problems to solve. We prefer helping US-based companies because of the funding that our center received for a long period of time from the state. We actually had preferred New York State companies, but that's, we've kind of broadened from there. And but it's, we're both US citizens, so I think it's safe to say we would prefer helping companies that are US based, or at least have a significant, if it's an international company, have a significant presence in the US and are employing a lot of US workers. So Glenn, you want to expand on that?
I think you covered it pretty much. I mean, we work with companies worldwide. The emphasis or most of the collaborations are with domestic companies or companies that have a domestic presence. But no, we're relatively agnostic to the location of the company that we work with.
So as far as, I mean, I think that's interesting because as far as what we do with the Advanced Textiles Association, and specifically this podcast is related to the Advanced Textiles Product Division of the Advanced Textiles Association. I know that's a mouthful. We're working on it. Don't worry, changes to come. But as far as that work, how has the work you've done related to fabrics and textiles, fabric products, and we use fabric products kind of broadly, but think about textiles, composite manufacturing as well as related to textiles. Can you tell us a little bit about, let's get broad, kind of what type of work you've done, and then let's get nitty gritty into a project or two that you found really fun and interesting.
Okay, well, I can start talking about the advanced composites. So composites are a combination of typically a polymeric matrix that's encapsulating a reinforcement, which is fibers, and oftentimes it's in the form of a textile. And so these textiles are specifically engineered for both manufacturing and also for performance. And we're talking about glass fiber, carbon fiber, Kevlar, other polymeric fibers. And then the matrices would be things like epoxies or different types of thermoplastics. So a lot of my research has focused on how to use these textiles in composites. And it's not easy. I mean, composite materials are just a wonderful engineering breakthrough. It's where you're taking two materials that by themselves have good properties, but when you mix them together, they have extraordinary properties. Mm-hmm. Things like, high stiffness, high strength, and low weight. So you see those used in industries like aerospace, automotive, renewable energy, et cetera, et cetera. And so a lot of my research is focused on how to simplify manufacturing, which is one of the there's many Achilles heels with composites, but that's one of the big ones, is it's very expensive to make composite mm-hmm. parts. And partly because you're dealing with fabrics. Think about, you take a fabric and you drape it over some kind of three-dimensional surface, and you get wrinkling and all sorts of things going on. So to make a nice laminate part, it's not easy. And so there's all sorts of technologies that are brought to bear to kind of make the part the way you want it, that it was designed to be, and also do it economically so that you can be cost competitive against other types of materials. So, I mean, broadly, that's where I really deal with textiles, advanced textiles.
Mm-hmm.
And so, there's a lot of automation involved, a lot of just novel manufacturing processing and the like. Glenn, you want to continue?
Yeah, I can say that, I mean, my experience or the work with textiles is primarily related to automation of some process or other related to the textiles. So
and that's definitely what the folks at the ATA want to hear. I mean, that automation side, and we'd love to hear a little bit about what direction that's headed in the industry, because I think we have a lot of folks who are old school manufacturers looking for kind of the next big thing.
So some of the work is related to advanced composites, like Dan just talked about, the problem of laying up the composite materials on complex curved surfaces, and how do you get those materials to lay in without wrinkles and bubbling and so forth on a piece of tooling. Some work associated with how do you use a robot to help a person who's laying up, again, composite materials on a form to build a better part. And more recently, been actually working with fabrics in the apparel industry and looking at automation in the apparel industry. So again, the focus really is on the automation associated with making the final product from the textiles.
So what's an example of you mentioned apparel manufacturing. What's an example of a project you've worked on in automation robotics that has helped advance the industry? Like something nitty gritty, anything fun and interesting?
Apparel manufacturing is fairly automated. Individual processes are fairly automated, but the connections between the processes is not very automated at this point. In other words, a person has to pick up each individual part and do something with it and so forth. So, we've done, one project related to, in which we designed a robot to pick the individual piece of a trouser and feed it into a serging machine to serge the seams on that panel prior to joining the seams into the garment. We've also automated the process of fusing, which is attaching the fusible to the fabric prior to joining the fabric in men's suits and these other kinds of apparel parts. But probably the most exciting and the funnest project related to working with a heavy vinyl tent material and using a swarm of robots to help the people do their job to join these large, heavy, unwieldy pieces of fabric that go together in making large structures like tents.
Yeah, so that's super related, and a plug is that we as Pavilion worked on that project as well. It's fascinating what Glenn and Dan have done at RPI on this one. We're talking about swarm robotics to pick up really heavy duty pieces of fabric and move them around factory floors. I think this, if people were not paying attention to the podcast, now all of a sudden they're hearing, wait a minute, moving big, heavy pieces of fabric around a factory floor automatically, that's something that I can get behind. So talk a little bit about that project.
I mean, the background is this goes back to what we were talking about earlier. What is the state of manufacturing today? So manufacturing large tents is fairly advanced, and but it's still a fair amount of work for the people on the floor. And the robots that we're developing today are they're not replacing anybody's jobs. What they're doing is they're helping people do the jobs that they have. So, when you're making a large tent, there's tons and tons of different processes, but one of them is joining the large pieces together. And there's lots of different ways of doing that. You can do RF welding, ultrasonic welding, and sewing and so forth. But we focused on RF welding. And if you imagine that, as you make a large tent, the pieces of fabric that you're wrangling they're big and they're surprisingly heavy, and it's a lot of work just to move these materials through the RF welding machine. Now the RF welding machine is fixed to the floor, so you're moving the tent material through the RF welding machine. And right now, prior to the robot swarm, it was all done by hand. So there'll be people tugging and pulling on this heavy material to move it through the RF welding machine. So what we developed was a swarm of robots that support the weight of the material and guide it through the welding process, so that the people who are on the welder can focus on doing a good job of welding, and not the heavy work of just manipulating and wrangling this material to get it through the welding machine.
Yeah, it's really a fascinating project. Anyone who's listening should check that out. And I just want to plug these folks from a market agnostic standpoint. And I think it's really important to look at what we do. The Advanced Textile Association and the Advanced Textile Product Division is really not look at a specific business market or vertical. So when I think of, you're mentioning tents, Glenn, but when I think of the capabilities here, you're talking about welding very large pieces of fabric that you move across the factory floor. Now I've pulled up the ATA's divisions: awnings, equipment, fabric graphics, fabric structures, geosynthetics, makers, marine, military, narrow fabrics, tarp, tent, and tarp and tent. So out of those 12 items, I think it is, 10 are relevant to this project. I mean, you're talking about fabric structures, geosynthetics, membranes, marine, awnings, making. I mean, it's really across every division. So while, Glenn, on this project, you were looking kind of at a narrow focus of a particular industry, within the fabrics industry, this is enormous and has enormous applications. So have you thought about some of those applications? I mean, that's kind of on us as industry, but I just want to emphasize that this is amazing, because it's not just about making tents, which is incredible. It's about making any big object.
Sure. Yeah. It's really about techniques to use a group of robots to help you manufacture a product using that involves these large pieces of heavy or unwieldy material. Tents is just happens to be the product that we focused on initially.
So, Dan, do you see projects like this coming down the pipeline as far as sort of larger manufacturing and swarm robotics?
Yeah, certainly. I mean, my focus has always been on kind of farther upstream with the textile manufacturing, but the manipulation of heavy materials, especially to make it easy on workers. We have OSHA kind of looking over our shoulders, we being the manufacturing community, to make sure we do things right and don't abuse workers, unlike other countries. And so you need helpers, in this case, robotic helpers, to do things that humans shouldn't or really can't do by themselves. Some of the work I do is again more farther upstream. One of the big changes with industrial fabrics is the getting away from synthetics, fossil fuel based. And some of the work we're doing at RPI is looking at natural fibers, things like hemp and flax. And we're going to run out of oil eventually, and either we can have a circular economy where we keep reusing these materials, but oftentimes they get downcycled. So every time you reuse it, it's for a lesser product, and eventually it's just not worth anything, and you either have to landfill it or burn it. So we're looking at natural fibers and how those can be used in composites and other higher tech applications.
So you're looking at natural fibers and processing them to enable them to be sort of competitive with carbon fiber and
Yeah.
fiberglass. Is
Yeah.
that right?
And carbon is a really wonderful material for a fiber, but it's really, really expensive and really difficult to manufacture. So we're not going to compete with carbon or some of the other high-tech ones, especially for things like aerospace, where performance counts above all else, or aerospace. But for the bulk of composite applications where you're using glass fiber and similar, actually natural fibers surprisingly have very competitive or similar properties, especially on a per weight basis. So one of the big problems with natural fibers is how they're processed. So imagine, if you will, you're a farmer and you're growing hemp or flax, and you harvest it, and then you bale it up and you send it somewhere, hopefully to get money and to be used in fabrics, maybe advanced textiles, might find themselves in, composite parts. But the current processing is pretty crude. And one of the reasons is because, at least in the US, there hasn't been a real economic reason to depart from synthetics. We're seeing that change, though, because of climate change and other things. And just the economics are changing. So, but the way they process these natural fibers really damages the fibers, and it compromises the mechanical properties. And you're not getting all that you can out of these materials. So we've actually come up with some new methods called a new decortication method. That's just a fancy word for meaning separating the fiber that's on the outside of the stalk, like a hemp stalk, from the inner woody part, which is called hurd or shiv. And we actually peel it off automatically, and we do not damage the fiber at all. And we're also coming up with methods of automatically degumming, which means removing the gums that are on the natural fibers that you typically don't want because they don't have really good properties. So you want to, if you're using it in a composite, you want to get rid of those gums and use the bare fiber. And so we've actually developed or are developing new methods that will help the industry, especially in the US. We're hoping we can kind of leapfrog what the rest of the world is doing.
So do you think this is going to lead to boats being made out of natural fibers, replacing fiberglass insulation, structural members? Is this relevant to any sort of composite that's high performance or medium performance?
Well, actually, we're seeing it now. I mean, if you look at the markets, let's say the advanced composites market is $100 billion worldwide. About 15 to 20% of that is biocomposites. So it's slowly, and it has a larger growth trajectory than regular composites. So you see companies wanting to use it. The only problem is that the materials coming out now are not, the properties are compromised because of how they're processed. So I think if you can, and I think there's also economic parity, maybe even because of lower embodied energy and lower cost manufacturing that comes with it, you can make an easy economic argument to replace a lot of the synthetics with some of these natural fibers.
That's incredible.
Yeah, I mean, that's the trend, and that's what we're trying to help with.
And so kind of talking about that project and then talking about the Swarm Robotics projects, what you're doing is really from beginning to end of a product. I mean, you're not necessarily taking one product from beginning to end, but if anyone wanted to work with you from the Advanced Textiles Association, you can really work with them on any part of the supply chain, early on materials processing all the way down to cut and sew. And I think that's a real benefit to your organization versus a, fiber expert, right? You guys are market agnostic, but you're also agnostic as far as the part of the supply chain that you help advance. Is that right?
I think that's fair. Glenn, you want to?
Yeah, I would say that's fairly accurate. Yes. Yeah.
And it's actually based on what the needs are. I mean, I don't want to speak for Glenn, but most of my work is reactionary, and it's by design, because I'd rather understand what industry needs, not what I think industry needs. And I think Glenn has probably is kind of the same philosophy, because I mean, certainly, there's the push and pull debate about technology, and certainly there are people that will push whatever they've developed, and it might be useful. But I mean, industry knows what they need, and what we try to do is look at, okay, how can, with our unique perspective, solve that problem. And oftentimes it doesn't require advanced knowledge in textile engineering and science, although we do appreciate what has come out of that research community. But oftentimes, especially with Glenn, you just say, okay, here's how the material behaves, or this is what's needed for the raw materials that are used in textiles, and it's not optimized, or it's not right. So what can we do to change that?
Well, I can say from firsthand experience working with you all on multiple projects that have really nothing to do with each other, you all are incredible at taking a problem and looking at it from a very neutral standpoint and solving it with industry knowledge and industry expertise, but also taking a bigger picture view and really simplifying things. Sometimes we manufacturers or we businesses get caught up in the weeds of what we're doing, and when we're working with folks like you, I know that you're capable of kind of making us realize that maybe this is actually simpler than we thought. And I think that's been a great part with my personal experience working with you all.
Yeah, well, I mean, one of the things with industry is that I mean, they have to make a profit, and they want to.
Well, you
ship
have to
product
make a profit too, I assume.
Well, we're technically a nonprofit, but and you have limited resources and time, and so and you have some very smart people that work for you, but the problem is time and resources, and sometimes you just have to go outside and say, oh, okay, maybe the academic community can help us with this, and that's why you've gone to Glenn or myself to say, hey, can you help us, because we can't do it right now, and hopefully we come up with something.
So if someone wanted to work with you, how would they approach you? Is it email Dan and Glenn, or what's the approach?
They send a check. Just kidding.
Like one of those big kind of comically large photo checks for presentation.
The easiest is probably old school email. Sure.
We'll have a link to some more information on the podcast as well, to make sure that our listeners are able to get in touch with you all. Because I do really think there's a link between industry and what you all are doing. I mean, I know there is. You're not in a vacuum, to your point. The industry is driving the conversation, which then helps you create the problem that needs to be solved.
And yes, and that trains the students that emerge from the university. And the closer, in my opinion anyway, the closer that our students are to real world problems, the better is their education.
That's great. We haven't touched on that, and so that'll be our last point that I want to bring up is students interested in RPI. The manufacturing innovation center is incredible. Can you talk a little bit about the student experience throughout this? Because I know there are some listeners here on the podcast who are students.
The student experience generally involves working directly on the research projects. Most of the work that I do is very hands-on. So our students they take the work that the training that they're getting in the classroom, and they get to apply it. So we have students in the lab working with their hands, building prototypes, testing prototypes, programming the robots, cutting the metal, doing the assembly, and doing the testing directly. So as much of that exposure as we can, we try to apply that to or provide that for our students.
So that's incredible, because when I think of being an engineer and hands-on work, it's hands-on theoretical in a lab where you're kind of doing an experiment that your professor tells you what to do and you write up a report. It sounds like there's some real problem solving and getting your hands dirty the way you would, Glenn, in wood shop or in taking something apart. Is that, I mean, that sounds like a unique engineering experience, which not all undergrads get.
Unfortunately, not all undergrads will have an opportunity to get that experience. But in our case, yes, we really value the contribution that the students make, and we really push them to get down and dirty and get involved with the hardware, the software, the robots, the equipment, the materials, and so forth.
Yeah, let me just expand on that. One of the other aspect of education is that with engineers is that, an engineer's superpower is his or her knowledge of physics and math and how it's applied to product development or the betterment of society. And so what happens is they do get that background, and some excel at the analytical side. Others struggle and they excel more on the hands-on side. So, we try to take all range of students, the run the gamut from almost pure hands-on to pure analytical, and they expose them to kind of a balance of both. What Glenn works on primarily is the hands-on part, and he's a wizard, of putting things together and designing. But one of the things that at least I try to do with my students and my other colleagues is have them understand what's the physics involved in what they're doing, and get to see firsthand the tangible result of that. And so, for example, we don't want them to just do trial and error experimentation and try to figure something out. They can use physics or other types of science to figure out, to get an understanding or an insight into what's going on. And that's reinforced by the experimental evidence or their observations. So, it's kind of for me, it's a mix. You really, you may take the student off to the side, say, you know what, that's what you saw, but what kind of theory or science is really governing what you're seeing? And can you use that to be smarter about what you do next? And so that's a real key part of what we try to do.
You're linking the hands-on with the analytical.
Yeah, you have to. And
absolutely.
But it's critical that they get to make and break. And sometimes they realize, oh, the trial and error isn't so good. Maybe what Glenn or Dan suggested is go back to the theory and see what the heck is going on, see if that helps.
That's great, and that's a unique experience, speaking firsthand from someone who got a Bachelor of Science in Engineering. It was very theoretical and not hands-on, and bouncing back and forth now as part of my job is super fun, and it sounds like your students actually get to do that as much as possible.
Yeah, well, you're making up for lost time, right?
Yeah,
you have your own playground now.
I guess, yeah. So, thank you guys so much for this. It's really been a pleasure to hear about the journey and hear about what you're doing. And I really would emphasize that folks from the ATA, formerly IFAI, should reach out to Dan and Glenn, because they're doing fascinating work, and they're doing fascinating work that can help you. And it can help you manufacturers, it can help you students, and it can help you industry leaders. So please do reach out. That's the point of this, is there should be action items. Listen, be interested, and reach out to Dan and Glenn and myself as well. And thank you so much. Any last parting words?
Well, this has been fun. And again, I hope from the perspective of Advanced Textiles that we've given the listeners some kind of new perspective, especially, from a highly technical point of view.
Not too technical.
Yeah, thank you also, Colin, for the opportunity here. My last comment would be, I guess, to any students who are listening is manufacturing today is not your grandfather's manufacturing. It's not the dirty, soiled kind of factories that you see in old textbooks. Manufacturing is very advanced. It's very clean. It's a great place to work. So I would definitely encourage you to consider manufacturing as a career.
Great. Thanks. We'll leave it at that. And we really appreciate having you all.
Thank you, Colin.
Thank you very much.
Thank you all for joining us in this episode of Talking Textiles. This podcast is brought to you by the Advanced Textiles Association, a not-for-profit association representing the international specialty fabrics marketplace. To learn more about events, workshops, and webinars ATA hosts throughout the year, visit us at textiles.org/events. Thanks so much.